Where are you sharing your code?
Where should I share? Like I can share on chat as well as on.
Yeah, you can share. Guys, give me a minute.
I just posted the code in the paste bin in the Telegram, and it gives some error of null pointer. I don't know how to fix it.
Yes, so let me see your code. Guys, am I audible now?
Yes, madam.
Okay, great. So still you have not answered my question. That was How many of you did that distinct problem, distinct numbers in a linked list problem? Let me just see. What is this delete at 2 function doing? Okay, that is the main function, right?
I mean, I made it explicit that I want to get rid at the second
Okay,
position.
why you made it for the 2?
I mean, to make it very, very clear that I want no other position other than 2.
Okay, so you are specific for the 2 position, right?
Yeah.
Let's just quickly give it a try. Okay, so you have taken current position equals to 0, node temp equals to node returned, fine, while current position is less than position traverse, so current position plus plus node return is equals to no. You have taken such complex names. Dot address next, fine. So now I'm at the position. When you are specific about, okay, you're passing in the position as 2, fine. So node returned dot address dot next equals to
So
address
I'm
next dot
writing it.
address next equals to system dot out. What you're printing? Node returned. Are you
So
printing node returned?
yeah, I'm just seeing that what position it is at right now. So that shows me.
And you have not even kept this. See, you are constantly moving this, right? Your node. But you should keep in mind that there can be a time that you're not able to reach the current position, like the position, and you are out of your index. So you should keep check of that
Yeah,
node. Please keep simple names from the next time. It is as simple as head dot next. Node return not equals to null. And okay. So this thing is the first thing you should do. And yeah, in current position is fine, node temp is fine, everything looks fine. Yeah. So now this that you're doing now, node returned. Sorry, I can't work with this code. So you are like pointing h dot next equals to.
I'm skipping one position by
Yeah,
putting.
that's right. H dot next, right? Now
Yeah,
imagine that your position is the last index. Okay. Then what will you do? Like it is the last element, it is the last index of the linked list, and now you have to delete it. What will you do in that case?
yeah, ma'am, brute force is not working. I was so much like simple thing was not working. I was not thinking of complex one.
No, but simple thing is not working because you should always think of that you are constantly moving your head, right? You are moving your head and
Yes.
you're not even checking for the position, that if position is in your, like, in your range or not. As I told you that your delete, like the position to be deleted should lie in the range from
Yeah.
0 till n minus 1. Okay, so
Right.
you are not keeping that check. You're not even checking if your h is reaching null or not. So obviously it's gonna give null pointer exception, right?
Correct. No,
So that's why it was doing.
but then I want to make it just simple that delete the second position and
Yeah,
still it.
delete the second position is fine, but you are see how your program runs is now that you're constantly moving your head. Okay, so when
Yeah.
it sees that head is constantly moving, there is no condition for head to get stopped, then obviously there will be a point where it will throw the null pointer exception, right?
when I'm seeing that current position is less than position, so it will skip the while loop.
I'm not sure how your current program is running. Maybe we can look at in it
Okay.
later, but these
Okay.
are few faults which it is having. Okay.
Yeah, yeah. Okay.
Okay. So please do try it.
Okay.
Yes. So you all have not done the distinct, I'm guessing. So I'll just directly move on to that. Vishnu, maybe you can discuss your code in the end, so you can share your screen. I can see where you are actually stuck on. So that will be a better way to do it, because right now it's little confusing for me. Okay, then. So for the distinct element, you need to keep certain checks what it will be. I'll just write here void distinct. And here you will be given the node head. Okay, so what are the basic checks that you need for this distinct function? Anyone?
What's the question again?
The question is like, if you want to print some distinct elements, then what are the basic checks that you need to do? In case if you are receiving the head which is null.
Yeah, null check.
So in that cases, you can simply return your head. No need to move further. Okay. Next is, you know that let's suppose your linked list looks like this. It's very similar to delete all function only. So I'll just delete 6, 6, 8, 8, and 9. If it looks like this, just keep your first element, because you know that you need to delete the remaining duplicates, but you need to keep the distinct one, like at least one element of its kind should be there, right? So for that reason, what we will do, we will start comparing from the next element. We don't want what is head, but we want to know what is head dot next. So here our while loop will also run in that way. While head dot next is not equals to null. Okay. In these cases, what you can do, you need to check if the data is equal or not. So you need to check here if h dot next dot data is equal your current head dot data. If this is the case, then in that case, what you can do, h dot this head now should be pointing to this, because this should be removed. So h dot next will be equals to h dot next dot next. Clear or not? Yes. This is the if condition. Otherwise, else, let's suppose the numbers were not similar. In that case, you simply need to move your head from head to head dot next. Clear? Just close your while loop and just close your function call. And that's it. Everyone, did you get this? Others in the class except Kishan? Okay. Three responses. What about the remaining 5 people? Got it. Great. Can you try for the unique? Now, since you know about the distinct, can I give you like 5 minutes of time and you can do the unique one? Its return type is node. And sorry. Yes. Okay, so I'll give you like 5 minutes of time. Give it a try. Yes. Anyone figured out the solution?
Yeah. Can I talk?
Yes, you can tell me your approach.
So two thing is different from distinct is first, since we have to return, we have to create another temp node where we will push in all the unique elements. So I created a temp node, and then everything like distinct remains same except for if and else they switch, where if the h.next.data is h.data, if they are same, then ignore it, else it will push into the temp node, assign temp a
I'll I'll
temp.
just try run your code right now. So you are saying it's 1, 1, 2, 2, 2, 4, 4, 6, and 6. Okay. And let's suppose here it is 8. So you are saying it is comparing with h dot data with h dot next,
Correct.
right? If it will
Yeah.
compare, it is same. So it will do like h dot next is equals to h dot next dot next. That means now this will be pointing to 2, correct?
Yeah.
The next time when it will check, what it will again check if h dot data is equals to h dot next dot data, right?
Yeah.
But this time it is different. So it will move your head to this head, right? Like 2. Getting me?
Um,
Again, when it will compare with this other next, it will be same. So it will point to this. Again, when it will compare with this 2, they will be same. So what it will be doing, it will be pointing to 4.
Oh, yeah.
Yeah. Then this 4, again, it will be same. So now at the end, 4 will be pointing to 6. 6 will be pointing to 8. Where did you got your unique element?
No, so one thing, if the data is
And
same.
Kishan, I hope you also got it that your code is not gonna work. Yes. Say Vishnu.
Yeah. So if the h dot next dot data is not equal to h dot data, not equal to, then assign h dot next to temp dot next.
Yeah, that's what I'm saying. When you will be comparing the time, this is head and this is h dot next now, right? After your change of links.
Yeah.
When this time you will be matching h dot data is not equals to h dot next dot data, right?
Hmm.
And at
Yeah.
this point, you will end up assigning it to the temp, which is wrong. Got
Okay.
it?
Yeah.
So that's what I am trying to point it out. Yes, anyone? Your guys are going right, but the only thing is you're not able to move the distinct, right? So for that, what can we do? It is slightly complicated, but will work. You take this as your milestone or as your unique element as of now. Assume like for now, you don't know anything that which number is unique, which number is not unique. So whatever first number you are taking, let's suppose 1, you are imagining that this is the unique number. Clear? This is whatever assumption is. So I'll just show you like what needs to be done. If I have assumed this particular one as an unique, now I'll try to compare it with the next element. If the other element is same to my current element, yes or no? Yes. When I'll find out that this is the same, then I should be having some kind of Boolean flag or Boolean stateless, which will indicate that the unique element which I assumed is not actually unique. Yes. And when I come out of that loop, like once I have figured out that all the ones are gone, I have figured out how many ones you have, and now I am going to 2, I'll come out of this loop after here. I'll check if my currently assumed element was unique or not. If it was unique, I will attach it to the temporary node as pointed by Vishnu. If it is not unique as indicated by the flag, then I will not attach it to my temporary node. Clear? And that's how your solution can probably work out. My code won't work. I have not actually seen your code, Prashant. Let me just see it quickly. Don't assign your node temp to null ever. First thing. Temp to data. No, Prashant, it won't be working. Okay, if you want, you can discuss your approach with me. I can tell you like why it won't work. Yes, guys. So did you got the approach that needs to be applied for the unique elements? Anyone in the class?
So as long as there is another element, we don't need to push it to temp. That's the logic.
As long as the same element is getting repeated in your linked list, Till then, you need not worry about the flag. I hope you are getting it.
Correct. Yeah.
Yes, others, are you coding it up? Pen, paper. How many of you want me to write the code for unique elements? Hello, hello. Yes, guys, I'm asking anyone in the class, maybe give today's time, it won't. It's working tomorrow. Everyone, are you agreeing on the fact that you want today's time for like seeing this code, or do you want me to directly write the code?
And one doubt I have, that flag,
We
should
need
it
time.
be
Okay.
the flag in which we are storing, whether it's duplicate or not? Is it an array, or should we put it in
Flag
another?
is just flag just indicate a yes or a no, true or false. It need not to be a array. You very well know if you need just two values, true or false, what should be used.
Yeah. So should it, why I'm asking is this, whether it should be an array or something, because there would be like some elements which may be in the middle, like one is consecutive. I understand we can easily capture it that there's a duplicate, but if one is in the middle, and then
If you
initially,
remember, this particular linked list is sorted.
okay, so in the first go itself we'll can get to know that whether it's duplicate in a flag.
Like it answers most of your question, right? Like every
Okay.
element in your linked list will be continuous. Count
Okay.
method, how, Aman, will you be using the count method?
Well, after transversing the data, and we will save it into list, and after that, if count of particular element is greater than one, then we will save into another list and we will return that list.
You can do that. So
Yeah,
for that also, like as soon as you are getting a second element similar, then also you need to traverse in the linked list until you find a new element, right?
I solved this question by linked list also.
No, what I'm saying is, even though you are getting the like count equals to 2 greater than 1, but then also you need to traverse on all the numbers before you get a new number on the linked list.
Yes, sir.
Yeah, so it is working fine. You can use the count method, that's right. Clear?
So is it good as compared with linked list, or we will purely work with linked list?
It's a good thing, but just think that instead of count, if you will be using flag means a boolean value, okay, and count means an integer value. Integer takes more space, boolean takes less space. So boolean is better than count, right? Otherwise, both the methods are fine. You need not worry that which is fine and which is not. Clear?
Yes, sir.
Okay. Yes. So anyone else having any other concerns? Okay, great. I'm giving you the time to look into this unique function, like unique method for today. So we'll look into another question for today now. So we have seen how to print a linked list in a reverse manner. So today we will see how to actually like we have seen so far only printing, but today we need to reverse the linked list actually. You will be given the head node. Okay. And you need to reverse the linked list. And you also need to tell me what will be the return type of this. Node because head is getting changed. That's right. So yes, any ideas how to reverse a linked list?
Do we want to preserve the old original node, original linked list?
Why
So,
will you want to preserve the original linked list? If you
oh,
want to reverse the nodes, then obviously you're going to reverse the links as well, right?
okay. No, I was thinking to print the original and the reverse. So, okay. So if we are returning node, that means we are preserving the old one also, because we are getting a new node after reverse.
So
So yeah, so we will have before the call a new old node, and after the call new node. So we will have in a way original as well as the final linked list.
you will be having it, but like what will you be doing with that? That's my question.
Oh, I mean, just for
The
comparison purpose.
question is like my point is you have 1, 2, 3, 4, and 5. Okay. You are reversing it and you're getting it as 5, 4, 3, 2, 1. You are still having the address of this, but what will you do with this? Because already the entire linked list is being changed. If you try to traverse with head.next, you will be getting it as null now after the reverse. So that's why I'm asking, like, what is your point when you're saying our head is still preserved? What you will be doing with that? Good, Bhuvnesh can
No,
maintain
so
a temp node with a null variable in recursion will reverse after that again. Yes, sorry, Kishan, you
Vishnu.
can try it. And no, I'm actually seeing Kishan's approach, and your approach is correct, Bhuvnesh. Yes, Vishnu, did you understood it?
No, madam. Actually, what I was thinking is that in the main method, um, if I am passing one parameter with original linked list, uh, even after the call of reverse, I can still have a handle on the original linked
No,
list.
no, you can't. It is very similar to the yesterday's thing
Okay.
that if you are deleting some of the node, if you are calling this delete function from your main function, okay, so
Yeah.
once a node is getting deleted from this after this function, if you try to access your linked list now, you won't be getting that node back. Clear? You
Okay.
understood that concept, right?
Yeah.
So if you understood this, then similar way, if you're calling this reverse function and you are reversing your links, then how can you imagine to get back the original linked list? Like, what's the point of it? Even if you store your current, like original head in your some temporary variable also before sending it to the reverse function, then also you won't be able to access this because these are some things which we are playing with the addresses. It's not something which is like relative or something. We are actually changing the addresses, and that's why we cannot retain it back. I
Okay.
hope it makes much more sense now.
Okay. Yeah.
So yes, for reverse, you can apply two methods. So one is the method is you can try reversing node by node. Like if you have to reverse this, like right now, one is pointing to two, but in the reverse method, two should be pointing to one. So for that, you can consider having, yep.
Ma'am, my approach would be inside the reverse method, create another linked list, and then while I'm traversing from 1 to 5, I will keep on assigning to. No, no, no. Sorry, go ahead.
Okay. So for this, as usual, we need to check if head is not equals to null. In that case, you simply need to sorry, my bad. If head is equal null, in that case, you need to return H. That's it. And the other condition will be, since you are now reversing it, so you will be having two nodes. One is previous. So right now, can you tell me what is the previous of one pointing to in the original linked list? Like right now, the next is pointing to 2, but the previous is pointing to null. So we will take previous equals to null as of now. Okay. And we need to traverse up to here and change the link till here. Like we cannot move beyond 5, right? So for that, see what will be the condition for while. As of now, I'm not writing the while condition. Next is what you need to do. You need to point 2's next should be 1, right? And 1's next should be null now. Yes. So for that, what can you do? H dot next should be equals to previous. Just a minute. So here it will be previous. Now you all can see if I do this stuff, then I will be losing my this node because I'm pointing 1 dot next should be equals to null. That is previous. So I'm losing my current node. Yes or no? So before pointing this h dot next to something, we need to store our next connection. So for that, I will take node temp equals to head dot next. After this, you can write here that head dot next is equals to previous. Clear or not? Now what should be done? You have pointed 1 to the null, and now you have in your temp h dot next, that is 2. What should we do with this 2? This node is set, right? The 1 is pointing to null. So now we need to set other node 2. For me setting up 2, we need to assign our head equals to temp. We should make 2 as our head now, and we should change our previous to, we should change our previous to. For 1, the previous was null. For 2, the previous should be 1. So we should interchange these two lines because otherwise head will change. So here it should be previous is equals to head, whatever your head was. And now your head will be temp. Clear? So for every node, we are changing its link one by one, storing it somewhere, then assigning it. And that's how we are moving forward. Clear?
No, ma'am, I'm still thinking.
Okay.
So I'm thinking that 2 is pointing to 1, which is done by the first line.
Mhm.
2 is assigned to the temp.
Hmm.
Then
The first line is something else. Your target for now is that one should be pointing to null. Okay,
correct.
one's next should be pointing to null. So once you have to point next to the null, you should store that previous link of h dot next.
Yeah,
And that's what temp is doing. Okay. Then you're pointing your h dot next to previous, which is nothing but null. Clear?
right. Yeah,
These two lines are understood, right? Now you finished up setting one. Okay, you pointed the h dot next equals to null. But now you need to take care of the other values as well, right? So
yeah,
currently your head was 1. So we set up that node. Now we should change our head to 2. So before that, if you change your head first, then you're going to lose your previous variable, right?
yeah, yeah.
So that's why I'm first assigning previous equals to head, whatever your head was, that is 1. And then I'm assigning head equals to temp, which is nothing but 2. And that's how one by one in this while loop, we are going to change the links. Clear?
Okay, yeah,
Is it clear?
yeah.
Sure. Now, can anyone tell me up to where this particular while loop should continue? What should be the condition?
Until head dot next equal to null.
Why head dot next equals to null? You need not point, like you need to change it for every head. So if you are here, you are changing for this head. If you are here, you are changing for this head. So you should be here to change for this head, right?
No, so before we started, the last element was pointing to null.
Correct.
So, so that's
So
why
it,
I said the check of last element should be equal to null.
no, just tell me in this first iteration, you are only worried about that your current head should not be null, right? Are you worried about that your next should not be null? Are you at all worried about this?
No, no,
Like if your linked list look like this is null. Okay, nothing is pointing over here. Are you worried about that here?
no.
No. You are only worried about changing the links for this particular node, right?
Yeah,
So in the while loop also it should reflect that while your head is not equals to null. As soon as it becomes null, then obviously you need to exit. Clear?
oh, yeah, yeah.
Everyone, is it clear? And Bhuvnesh, I saw in yours, the condition was head dot next. So I hope you also understood that it should be head. Okay, then. And yeah, the same question can be done via recursion. So I'll just quickly explain that. But before that, in this example, just tell me what should be returned. At the end, you need to return the head, like the reversed node or the head node of the reversed linked list. So what should be returned at the end?
Temp.
Are you sure? See, temp is always containing h dot next. So when it will be at 5, it will be containing null. Head dot next is null. But you need to return the address of 5, which is nothing but contained in previous. So at the end, you need to return previous. Analyze this code on your own once. It's very interesting way how you are reversing the linked list, like node by node. It's actually very interesting. Those who are like right now trying to figure out what ma'am is teaching, So for that reason, I'm saying that analyze it on your own. And right now, if anyone needs the analyzation, I can analyze it too for you. So yeah, how many of you want me to analyze this code right now? Anyone in the class would be good. Okay, I'll just do it. So you all have understood for one, right? Like I need not go to one again and explain it again with the null and all. So I'll just quickly write here the three things. One is previous. One is where is your head going on right now? And one is temp, which is pointing to your head dot next. Okay, so in your previous, you saw like first iteration, previous was null, your head is 1 and your temp is 2. Okay, so it continued and it found the link like 1 is pointing to null. Other time when it iterated in the while loop, it checked if h is not equals to null. So after the iteration, like first iteration, your head has been changed to 2, your previous has been changed to 1, and temp is still unknown as of now. So it will check if head is not equals to null. Is it equals to null? No, right? It is having some value. So it will come in, it will assign the temp value as h dot next, which is nothing but 3. Now it will point h dot next to previous, which is, this is your head. It is pointing to its, like it's next to the previous, which is 1. Again, it will update the values for previous. Previous will be updated with 2. Now head will be updated with temp, which is nothing but 3. Clear? Again, it will go up and check if h is not equals to null. So h is not equals to null, obviously. It will come in and assign your temp as 4, which is head dot next. Now h dot next will be pointing to previous. So your head is 3. It is pointing to its next, which is 2. Like it is pointing to its previous, which is 2. After that, again, reassigning of the value. So previous will be changed to head 3. Head will be changed to temp 4. And temp is still unassigned. Again, it will check if h is not equals to null. So head is 4 right now. Obviously, it's not null. So it will come in and change, like make your temp is equals to h dot next, which is 5. Everyone, are you getting this? Yes, no, anything? Okay. So again, what it will do for these reasons, for this particular iteration, it will point head dot next to previous, which is 4 is pointing to 3 now. Again, previous will be updated with 4. Head will be updated with 5. Temp is still unknown. Okay, so you all can see that now when it will check h is not equals to null, it is running for 5, right? If we would have written here h dot next not equals to null, then for 5 it would not have entered the while loop, correct? And hence we would have one node which would not have been reversed. Clear? Is it clear? Okay, fine. So now it is 5. When it will come in, it will assign temp equals to h dot next, which is nothing but null here. So now it will be null. Head dot next will be pointing to previous. So 5 will be pointing to its previous, which is 4. Now previous will change to head. Your head is nothing but 5. Head will be changed to temp, which is nothing but null. Okay. And now again, when it will run, it will check if h is equals to null. H is not equals to null. This time the condition will fail. It will come out and return the like reversed head of your linked list, which is previous, which is 5. So 5, you know, is connected to 4. 4 is connected to 3. 3 is connected to 2. 2 is connected to 1. 1 is connected to null. Hence, your linked list is reversed. Clear, guys? So it's basically like we tried to reverse our singly linked list using the concept of doubly linked list, that is using previous node as well.
Just one quick question. I know it's like a very naive question. What would happen if we just return node itself, like a head?
Null will be
Will
returned.
no, return the last statement instead of return previous. Will just do return h.
Yeah,
So
I'm
will
saying it will return null. See, head is null, right? It will return null.
okay. Okay, let me try it out here.
You can try out all the kind of like doubts you are getting in your head, and you will be getting the clarity better in a better way.
Okay.
Okay, then, so we will just discuss quickly the recursive approach and then we'll close the call. So, yep. Node reverse. You will be given the node head. In this case, since we want to reverse it using recursion, we assume that if I am gonna pass in the reverse function h dot next at any point, yeah, correct. If I am passing h dot next in the reverse function, it is gonna give me the reversed linked list. This is what my assumption is. Okay. So when it will reverse, let's suppose your linked list look like 1, 2, 3, 4, and 5. So if I'm passing, this is my head, right? If I'm passing head dot next, that means 2. So it will reverse this linked list. That means in the R list, I will be getting my linked list as 5, 4, 3, and 2. This one is still remaining and we need to attach it to our reversed list. Everyone, are you able to follow this or not? Everyone else in the class?
No, madam. Once again. So you're passing one and then calling reverse.
Yeah, you're passing 1 over here and now you're again passing h dot next, that is 2. You already got 1, you are trying to pass 2 now, and you're assuming that this reverse function is gonna give you the reversed list.
Right.
Aman, we didn't fixed 1. It is like when we got this function definition, it was already assumed that if we are passing 1 as the head node, then it is gonna give us the reversed list, right?
Okay.
So that's why when already we have been given this function, so I'm just trying it with h dot next. Clear? Like, you know, na, that always when there is a recursion, if you have been given n, then we move towards n minus 1, then n minus 2 and all. Similar way I am moving here. Clear?
Yes, sir.
Okay. So I have got this reverse linked list. I need to attach 1 to here. How will I attach this? So for that, you know that in your previous linked list, this 2 was nothing but head dot next, yes or no?
Yeah.
In your current linked list, you need to attach this head dot next to head dot next dot next. Like, sorry, my bad.
Just head itself.
Yeah, just head itself, right? How can you attach that? You need to attach, this was your head dot next already. So I'll just write it as head dot next. And to its next, I want to attach, right? So I will again write one more next. Are you getting this or not? And I need to point it to head. Clear? Okay. This was your head dot next. You need to point its next to 1. So this itself is h dot next. You need to point its next. That means again dot next will be added, equals to head itself. Did you got it now?
What will be the base condition while head is not equal to null?
Yeah, sorry.
So I'm thinking that what will be the base condition? This is fine, but base condition, because this has to be contained in a base condition at the top if head is not equal to null. My question is like, what will be the base condition, like starting point of this? Why I'm asking is because if we are checking that head is not equal to null, it will keep on going.
Correct. Just you identify the base condition and tell me. It will be interesting. Are you sure with, sorry, with head it will work? Like head equals to null. Just imagine the situation where your head is not equals to null, okay? Here, I'll write here h not equals to h, sorry, h equal null. In that case, you need to return head itself, okay? Now, what will happen in the condition where you just have one element? What will happen? It will come in and check if h is equal null. It will fail. It will go to this R list and it will be passing null to its reverse, right?
Yeah.
So when it will happen, it will go up again, check if h is equals to null. It's true. So it will return head back to this. That means your R list will be containing null. Getting this?
Yeah.
Yeah. Now here, when you will be doing it, it will be h dot next, which is null. Null dot next, which is nothing but null pointer exception. Clear?
Yeah.
So in that case, you need to take care of that. Here also there is a possibility of getting a null pointer exception. So if it is a single element, there is no need to reverse it also. We need to bother about if there are two elements in a list. So for that reason only, it should not be h, it should be h dot next. In case of iterative, it was h not equals to null, because in that case, we were reversing each and every node. Okay, that was our basic concept. But here we are more bothered about reversing the entire linked list altogether. Clear? Though it is doing the same stuff, but since it is recursion, the condition is slightly changed. Clear, everyone? Okay. And yeah, one more thing, which I forgot, that right now also, this head is still pointing to this head dot next, that is 2. So we need to, we need to undo that particular link as h dot next equals to null. And then at the end, you need to return your R list or return reversed list. Clear, everyone? Just, I'm not giving you the analyzation of this as of now. Try to analyze it on your own. And yeah, it's a really interesting thing if you do it. If no, then just tell me in the class that, ma'am, please can you analyze it on our behalf? I'll do it tomorrow. Clear, everyone? So these were 10 brief, or you can say 10 main simple questions in the linked list, which we finished up today. Don't forget to do the unique problem today itself. From tomorrow onwards, we'll see what kind of questions being asked in the linked list. Linked list is one of the very famous topic of the interview, like very favorite topic of the interviewers. Like they generally ask 1 or 2 questions from the linked list. Those who have sit for the interview must have observed that.
Ma'am, is map related to linked list? Because all the nodes are connected with each other.
Sorry, what did you say, Aman? What
Map,
is connect?
yeah. Is map connected to linked list? Because all the nodes are connected.
So,
No, I am asking about is map connected with linked list? Is
no, I
related to
am.
linked list?
Probably it can be, probably it can't. You all learned about the map, right? You all attended the hash map class. Yes or no?
Yes,
Do you all remember its implementation?
no.
No, that's too bad. Yes, that's right. That questions you will definitely get in the class, Kishan. So need not worry about it. Were you able to do it in the interview? I learned and wrote. Oh, okay, great. Okay, then I'll just drop off and we'll see you all tomorrow. Thank you.